Okay, students, good morning. Today we will do some question from class 8 of mathematics. This our topic is trigonometry. Let's start from question 1. Prove the following identities. Now, first of all, question number 1A. Solution. Here we have to prove 1 upon we have to prove sin A plus cos A whole square plus sin A minus cos A whole square equal to 2. Now LHS equal to sin A plus cos A whole square plus sin A minus cos A whole square. Okay, students, this first part in the form of A plus B whole square, and second part is in the form of A minus B whole square. So, using formula, we can write sin square A plus 2 sin A cos A plus cos square A. By using formula of A plus B whole square equal to A square plus 2AB plus B square plus, similarly for this second part, this is in the form of A minus B whole square. So, using formula of A minus B whole square, A square minus 2AB plus B square. So, we can write sin square A minus 2 sin A cos A plus cos square A. Here, we use the formula of A plus B whole square equal to A square plus 2AB plus B square and A minus B whole square equal to A square minus 2AB plus B square. Next step, this positive to sin A cos A, negative to sin A cos A. These two terms cancel each other. Now remaining is sin square A plus sin square A. It makes 2 sin square A. Similarly, cos square A plus cos square A. It makes 2 cos square A. Over here, we can take 2 common. So, after taking 2 common, sin square A plus cos square A. Then, we know that sin square A plus cos square A is equal to 1. So, 2 times of 1. So, 2 1s are 2. That is our RHS. So, we can write this equal to RHS. So, proved. Okay, students. Now, we go to next question, 1B. Let's start 1B. 1B, we have to prove 1 upon tan A plus cot A equal to sin A dot cos A. Now taking LHS, 1 upon tan A plus cot A. Now, since RHS in the form of sin cos, so this tan and cot must be changed in terms of sin cos. So, on the first step, we can write 1 upon tan A. For tan A is equal to sin A upon cos A by using cosine relation. Similarly, plus for cot A, we can write cos A upon sin A. On both, we use cosine relation. Tan A equal to sin A upon cos A and cot A equal to cos A upon sin A. After this, 1 upon, on the denominator we can take LCM, cos A sin A. So LCM is cos A dot sin A. Then on the numerator part of numerator, sin A multiplied with sin A, it makes sin square A plus cos A multiplied with cos A, cos square A. But sin square A plus cos square A, its value is 1. So on the next step we can write 1 upon 1 by cos A dot sin A. This equal to this. Denominator fraction make reverse. So 1 multiply with cos A sin A upon 1. So this equal to sin A dot cos A, which is our RHS. So we can write RHS proved. Okay, students, now we go to next question. Question number 1C. Okay, students, now next question 1C. On C, we have to prove sin cube theta plus cos cube theta all upon sin theta plus cos theta. This equal to 1 minus sin theta dot cos theta. Now taking LHS, we can write sin cube theta plus cos cube theta all upon sin theta plus cos theta. Okay, students, let us focus on the numerator part. This is in the form of a cube plus b cube. So we can use the formula of a cube plus b cube. A plus b times a square minus ab plus b square. Okay, let's apply the formula. Sin theta plus cos theta, then sin square theta minus sin theta dot cos theta plus cos square theta all upon sin theta plus cos theta. Here we use the formula of a cube plus b cube equal to a plus b times a square minus ab plus b square. Okay, students, on the next step, this sin theta plus cos theta on the numerator and on the denominator same factor. So these two cancel each other. Then remaining part is sin square theta minus sin theta dot cos theta plus cos square theta. But this value of sin square theta plus cos square theta, its value is 1. So we can write 1 for sin square theta plus cos square theta minus sin theta dot cos theta, which is equal to RHS. So we can write RHS root. Okay, students, now we go to next question, question number 1D. Okay, students, on 1D, we have to prove 1 upon 1 plus cos A, 1 upon 1 plus cos A plus 1 upon 1 minus cos A equal to 2 cosec square A. Okay, start from the LHS. We have 1 upon 1 plus cos A plus 1 upon 1 minus cos A. On the first step, we can take LCM from two denominators. Here LCM is 1 plus cos A and 1 minus cos A. Then this first one multiply with 1 minus cos A and second one multiply with 1 plus cos A. And there is 1 multiply with 1 minus cos A. It makes 1 minus cos A plus 1 multiply with 1 plus cos A. It makes 1 plus cos A. Whole upon on the denominator this 1 plus cos A plus B form, 1 minus cos A minus B form. So it makes A plus B times A minus B. So its formula is a square minus b square. So 1 square minus cos square a. For 1 square we can write just 1. We know that 1 square is 1. So use the formula here. This a plus b times a minus b equal to a square minus b square. We use this formula. Now next step, negative plus a, positive plus a. Both cancel each other since one is negative and the other positive. So remaining part is 1 plus 1. It makes 2 upon 1 minus cos square a, that is sin square a, because 1 minus cos square theta equal to sin square theta. We know that. Then this equal to 2 upon sin square a. Reciprocal of sin square is cosec square. So we can write 2 cosec square a. You know that 1 upon sin square theta equal to cosec square theta. This equal to RHS and okay students, now we go to the next question 1a. Now question number 1a. Solution here, we have to prove 1 upon sec a minus 10a. 1 upon sec a minus 10a equals to sec a plus 10a. Now, LHS equal to 1 upon sec a minus 10a. From the identity relation, in terms of sec and 10, sec square a minus 10 square a equal to 1. So, instead of this one, we can write sec square a minus 10 square a from the identity relation. All upon sec a minus 10a. As we know, sec square theta minus 10 square theta equal to 1 from the identity relation. Next step, this is in the form of a square minus b square. So we can factorize this by the formula a plus b a minus b. So here sec a plus 10a and sec a minus 10a. All upon sec a minus 10a. You know that a square minus b square equal to a plus b, a minus b by using this formula. Then this sec a minus 10a, sec a minus 10a, these two factors cancel each other. Now remaining is sec a plus 10a, which is RHS proved. Okay students, now we do the same question from second method. This question can be by using another method. Look at here. LHS equal to 1 upon sec a minus 10a. This equal to 1 upon sec a minus 10a. This term multiplied by its conjugate of the denominator. Sec a minus 10a, its conjugate is sec a plus 10a by using conjugate of denominator. If conjugate is a minus b form, then denominator is a minus b form, then its conjugate becomes a plus b form. If denominator is a plus b form, conjugate becomes a minus b. So, yeah, a minus b form, so conjugate is a plus b form. So, sec a plus 10a upon sec a plus tan a. Now multiply each other, upper part with upper part, lower part with lower part. That means numerator with numerator, denominator with numerator. Again, sec a plus tan a ones are sec a plus tan a, sec a plus tan a. Whole upon this a minus b form, this a plus b form. So it makes a square minus b square. So here sec square a minus tan square a. Now next step, sec a plus tan a. All upon this sec square a minus tan square a. By using identification, it is equal to 1. So, it's equal to sec a plus tan a, which is RHS. So, it is proved. Okay. Now, we go to next question. 1F. Okay, student, now 1F. What else? We have to prove 1 minus sin to the power 4a whole upon cos to the power 4a is equal to 1 plus 2 tan square a. Now, the LHS is equal to 1 minus sin to the power 4a whole upon cos to the power 4a. This equal to this numerator is 1 minus sin to the power 4a. We can send it in terms of a square minus b square form. So 1 is 1 whole square minus sin to the power 4a is sin square a whole square. So it is in the form of a square minus b square whole upon cos to the power 4a. Now this numerator can be factorized by using formula of a square minus b square equal to a plus b times a minus c. So 1 plus sin square a times 1 minus sin square a whole upon cos to the power 4a is equal to 1 plus sin square a. We know that 1 minus sin square a is equal to cos square a whole upon cos to the power 4a, that is cos square a times cos square a. So this one cos square a, another cos square a on the denominator cancel each other. Remaining part is 1 plus sin square a whole upon cos square a. Now breaking it, we can write 1 upon cos square a plus sin square a upon cos square a. We know that 1 by cos square a is equal to sec square a, since the reciprocal of cos is sec, plus cosine formula sin upon cos, that is tan. So sin square a upon cos square a, that is tan square a. But RHS is in the form of tan. So again we need to take the sec square a in terms of tan. So we know that sec square a equal to 1 plus tan square a. Sec square a equal to 1 plus tan square a plus tan square a. Finally 1 plus this tan square a and tan square a. Writing together, it makes 2 tan square a, which is our RHS. So we can write RHS and then root. Okay, students. Now we go to next question. Question number 1G. Let's start 1G. On G, we need to prove sec square a dot cos square a is equal to tan square a plus cot square a plus 2. Now we have this equal to sec square a dot cos square a. But RHS is in the form of tan square a and cot square a. So we need to change this sec square in terms of tan square. and cosec square in terms of cot square. So we know that sec square A equal to 1 plus tan square A. Similarly, cosec square A equal to 1 plus cot square A by using identity relation. Now multiply these two terms with these two terms. So 1 multiply with 1 plus cot square A. Similarly, plus tan square A multiply with 1 plus cot square A. Then 1 ones are 1 cot square A. 1 into cot square A, cot square A plus tan square A ones are tan square A plus tan square A multiply with cot square A. Tan square A dot cot square A. This equal to 1 plus cot square A plus tan square A plus tan and cot are reciprocal of each other. So tan square A dot cot square A, this equal to 1. Since cot square A equal to 1 upon tan square A. So tan square cancel. So we can write this equal to 1. So finally we get this equal to tan square A plus cot square A plus 1 and 1 adding together it makes 2. That is our RHS. So you can write RHS proved. Okay students, now we go to next question. Yes. Now, here we have to prove the square root of 1 plus sin A all upon 1 minus sin A equals to sec A plus tan A equal to 1 plus sin A all upon cos A. In this question, we have three parts. This first part is left hand side. This middle part is middle term, empty, and this last part is right hand side. So we can start from LHS. Here LHS equal to square root of 1 plus sin A all upon 1 minus sin A. Now we can use conjugate of denominator. Denominator is in the form of A minus B. So its conjugate is in the form of A plus B. So we can apply conjugate over here. This equal to 1 plus sin A all upon 1 minus sin A. Within root apply conjugate. So its conjugate is 1 plus sin A upon 1 plus sin A. Now this equal to 1 plus sin A multiplied with 1 plus sin A. It makes 1 plus sin A whole square all upon 1 minus sin A multiplied with 1 plus sin A. A minus B, A plus B. So 1 minus sin square A. A plus B, A minus B. It makes A square minus B square. So next step is square root of 1 plus sin A whole square all upon 1 minus sin square, that is cos square. So this equal to 1 plus sin A all upon cos A. Since square and square root cancel each other, so that is our RHS. We got RHS. Again, RHS equal to 1 plus sin A all upon cos A. This equal to 1 upon cos A plus sin A upon cos A. So 1 upon cos A, that is sec A, plus sin upon cos A, that is tan A. This is middle term empty. Therefore, LHS equal to RHS equal to empty. All three are equal. So, it is proved. Okay, students. Now we go to next question. Question number 1I. On 1I, we need to prove that square root of sec theta plus 1 whole upon sec theta minus 1 is equal to cosec theta plus cot theta. Now, here is equal to the square root of sec theta plus 1 whole upon sec theta minus 1. Now, first step, this sec convert in terms of cos. So, we can write square root of 1 upon cos theta plus 1 whole upon 1 upon cos theta minus 1 is equal to the square root of, now taking LCM within root, the numerator and denominator. So, this is equal to 1 plus cos theta 1 the cos theta whole upon cos theta whole upon 1 minus cos theta 1 the cos theta whole upon cos theta. This denominator part cancel each other. Now remaining is 1 plus cos theta whole upon 1 minus cos theta. Now applying its conjugate over here, we can write this multiply with 1 minus cos theta. Its conjugate is 1 plus cos theta whole upon 1 plus cos theta. This is equal to square root of 1 plus cos theta whole square upon 1 minus cos square theta. 1 plus cos, 1 plus cos. It makes 1 plus cos whole square. 1 minus cos, 1 plus cos. It makes 1 minus cos square theta. A minus b, a plus b, a square minus b square. Since 1 square is 1. So this is equal to square root of 1 plus cos theta whole square all upon 1 minus cos square theta, that is sin square theta. Now this is equal to square and square cancel. So remaining part is 1 plus cos theta whole upon sin theta. Now breaking it, we can write 1 upon sin theta plus cos theta upon sin theta. But 1 by sin, that is cosec. So cosec theta. Similarly, cos by sin from cosine relation, that is cot theta. That equal to RHS. So we can write root. Okay, students. Now we go to next question J. Now on the J, we need to prove the square root of 1 minus cos theta whole upon 1 plus cos theta is equal to cosec theta minus cot theta. Cosec theta minus cot theta. Now LHS equal to square root of 1 minus cos theta whole upon 1 plus cos theta. Again, on this question we use conjugate of the denominator. So we can write 1 minus cos theta upon 1 plus cos theta. This multiplied by denominator is 1 plus cos. So its conjugate is 1 minus cos. So 1 minus cos upon 1 minus cos. Next step, 1 minus cos multiplied by 1 minus cos. It makes 1 minus cos theta whole square all upon 1 plus cos multiplied by 1 minus cos. A plus b, a minus b becomes so 1 minus cos square theta. Since 1 square is 1. So this equal to square root of 1 minus cos theta whole square all upon 1 minus cos square theta, that is sin square theta. And square root cancel each other, so remaining part is 1 minus cos theta whole upon sin theta. Now breaking it, we can write 1 upon sin theta minus cos theta upon sin theta. This equal to 1 upon sin, that is cosec theta, cos by sin, that is cot theta. Cosec minus cot, that is our RHS, so equal to RHS. Okay students, now we go to next question, question number K. Now look at question number K. Here we have to prove the square root of 1 minus sin A whole upon 1 plus sin A is equal to sec A minus tan A. Now LHS is the square root of 1 minus sin A whole upon 1 plus sin A. Again, we use the conjugate of the denominator over here. So 1 minus sin A whole upon 1 plus sin A. This conjugate of 1 plus sin A is 1 minus sin A. So multiply by 1 minus sin A whole upon 1 minus sin A. This equal to the square root of 1 minus sin A, 1 minus sin A. It makes 1 minus sin A whole square whole upon 1 plus sin A, 1 minus sin A. It makes 1 minus sin square A. This equal to square root of 1 minus sin A whole square whole upon 1 minus sin square A, that is cos square A. So square and square root cancel each other, so 1 minus sin A whole upon cos A. Now breaking it, we can write 1 upon cos A minus sin A upon cos A. So 1 upon cos A, that is sec A, minus sin by cos, that is tan. So sec A minus tan A equal to RHS. So it is proved. Okay students, now we have the last question of 1, that is 1L. Let's start 1L. Here we need to prove 1 minus cos to the power 4 alpha whole upon sin to the power 4 alpha equal to 1 plus 2 cot square alpha. Now LHS is 1 minus cos to the power 4 alpha whole upon sin to the power 4 alpha. Now this equal to 1 whole square minus cos square alpha whole square, making a square minus b square form whole upon sin to the power 4 alpha. Now using formula of a square minus b square, that is a plus b, a minus b. So here a 1 plus cos square alpha times 1 minus cos square alpha whole upon sin to the power 4 alpha. This equal to 1 plus cos square alpha. Now 1 minus cos square alpha, that is sin square alpha whole upon sin to the power 4 alpha, that is sin square alpha dot sin square alpha. This sin square alpha and this cancel. Remaining part is 1 plus cos square alpha whole upon sine square alpha. Now breaking it, we can write 1 upon sine square alpha plus cos square alpha upon sine square alpha. Now this equal to 1 upon sine square, that is cos square alpha, plus cos square upon sine square, that is cot square alpha. But RHS is in the form of cot square, so again we need to change this cos square in terms of cot square. So we know cos square alpha equal to 1 plus cot square alpha plus cot square alpha. Finally 1 plus this cot square alpha plus cot square alpha. It makes 2 cot square alpha. 1 plus 2 cot square alpha. So that is our RHS. Equal to RHS and okay students, this much for today. See you soon. Have a nice time.